So welcome everybody. Thank you for joining us on this snowy Sunday afternoon. I hope everybody's nice and cozy. Um, and I'd like to thank Mr. Michael Weitzner for joining us today. I'm going to leave his credentials. He can give a little explanation about his own credentials, but he has been working with the Friends of Quabbin and the DCR on a historic bridge that is in New Salem. And this he did present, I think, 2 years ago or 3 years ago, and this is actually a follow-up presentation about the work that was done this past fall. So, Mr. Weitzner, you're all set to go ahead whenever you're ready.
Thank you, Maria. Welcome, everybody. Michael Weitzner here. I'm a dry stone waller, meaning I build walls without mortar. I also do some mortared work, but I have a qualification from the Dry Stone Walling Association of Great Britain. That is Master Craftsman, the highest level available of certification. And I'm also an instructor and an assessor for their certification system. So that's kind of my background. I've been
Sorry, Michael, you were accidentally muted. Um, so just unmute yourself. I'm sorry.
okay.
All right, so you were explaining that you have a certification from the British stonemason.
Yes, so I'm a Master Craftsman through the Dry Stone Walling Association of Great Britain, and I'm also an instructor and a an assessor for the certification system. Um, so that's one of the reasons why people contacted me when there appeared to be an issue with the bridge at New Salem. Actually, it's a bridge on the Orange to Millington Road, as it was before the formation of Quabbin. Well, the filling in of the Quabbin Reservoir. Um, so Orange, of course, is still where it is, but Millington is now no longer a village. So that road was essentially cut off, and the bridge is right at the northern edge of the Quabbin Reservation. It's at Gate 30 for those of you who might be interested in knowing exactly where. Just a couple of hundred yards down from the intersection with 122. So the um, the bridge was built in 1866, and we can uh, launch into it here. I think I'll share my screen. Um, let's see. So here we are. Can you all see this? Hopefully it's visible to everybody. So in 1866, a man named Adolphus Porter took charge of making this bridge over the middle branch of the Swift River on the Orange to Millington Road in New Salem. And this is a view here of the bridge in question. And just an interesting note, in the foreground here, you can see some piles of stone. And these are the remnants of the abutments of a former crossing, probably a wooden bridge, maybe a covered bridge. I don't know. It doesn't really matter. But just an interesting point that they were there, and probably either they had failed, and then that bridge had failed, and then this one was built, or they just wanted a better bridge. So we don't really know the answers to those possible questions there, but so it's a stone arch bridge. It's a dry stone arch bridge, which actually is not unusual, but for a bridge this size, it's more common for them to be mortared. And mortar does give some advantages structurally to the bridge. Um, but here we are. This is the arched portion of the bridge right here, and many of you may be wondering, well, how do bridges like this get built. And here's a picture that shows a little bit of that. Um, and this is in Hillsborough, New Hampshire, sometime in the 1800s. I don't know the exact date. But here we have the arched part of the bridge, and under it you can see a framework, and that framework is called a centering, or a false work, or a form work, um, or just a framework. And it's built after the abutments are in place, so they would build this part of the structure first down here, and then this formwork would be placed, assembled in place, and then the vault, which is the arched part of the bridge, would have been built over the top of the framework. And you can see here that these stones are very carefully cut and placed, very tight. And this is a granite bridge built to a very high standard. This one is mortared, unlike the one in New Salem. And here you can see uh, the walls that rise above the abutments and the arched portion of the bridge, the vault. The walls that rise above it and support the roadway, and they take their name from this portion here, which is called a spandrel. So this little triangular bit that runs over the haunch of the arch or the vault is called a spandrel. And so this entire thing is called a spandrel wall. So there are spandrel walls in 4 quadrants of the arch, typically, if it's a freestanding bridge, which most of them are. So you can see here a derrick, and this pair of poles is actually a derrick, and it's standing on a pivot. There's a pivot at the base, which you can't see very well here at all. It's hidden behind the top of the stonework there. And on the derrick, there is a block and tackle. You can just see the block here, and there's a chain hanging from it, and this guy's holding on to that, the end of that chain. And this allows stone to be hooked onto and raised and lowered, and this arm here can swing out, and that provides the radial movement, allowing the stones to be lifted and moved into place and dropped into wherever they're needed. And you can't see it in this picture because of, let me see if I can do this. There we go. Oh no, I didn't mean to do that. I'm sorry. How do I do this? Here. Okay. So over here you can see this is a steam engine, and that's what's providing the power to run the derrick. And in earlier times, before steam, or maybe even at the same time, because these technologies tend to be concurrent, they might have used a team of oxen the instead of the steam engine. And down here you can see another steam engine. Let's just see it here. And this thing here is a guy wire that's running to the top of another derrick that you can't see in this picture. So they would have 2 derricks working and lifting stone, moving it around. Take a look at this wall. It's made up of big, long blocks of stone. And you'll notice that there is no joint, no vertical joint that has another vertical joint on top of it. Okay, all of these joints are crossed. And that's an important feature of strong dry stone walling. Let's look at our bridge. So this is looking at the bridge in New Salem from downstream, just downstream of it. And here's the abutment wall right here on one side. This is the left bank. The convention is that when you look downstream, left bank is, of course, on your left and right on the right. And this is the other abutment wall here. And you notice that there's a little ledge on top of this. And that ledge is where I'm pretty sure where the formwork would have rested, the formwork to build the vault here. So as you can see, these stones are blocky, and they were shaped. You can see the drill marks in this one, for example. Um, and so they were drilled and split into blocks and then maybe shaped a little further, but they're very coarsely shaped. And this bridge has actually, this vault has actually shifted some. So if you look here, you can see this is a bit flatter here than it is here. This is rounder. And you can see here how this stone, well, these stones here have all dropped a little bit into the middle compared with these here. So they, of course, if there was a formwork here, they would have all been on the same surface, and that would have, oops, been straight. I didn't mean to go forward there. But so there's been some shifting of stone. A lot of these voussoirs are quite small. Um, Ideally, the length in this direction, the radial direction, right? This is the radius here from the center of the center point of the arch outwards is a radius. So all of these stones are arranged radially. You can pretty much see that. Um, the distance from this surface's edge, the visible surface to the outside, ideally should be somewhere between 1/5 and 1/10 of the total span. And you can see that these are all pretty small in that dimension. They're not quite reaching that. So there's a factor in why this might have shifted. Another factor might simply be the quality of the shaping, the accuracy of the shaping, precision, I should say, not the accuracy. Um, so there's a vault, a view of the vault from the downstream end. And you can see here the walls, the spandrel wall on either side is made up of pretty rough stonework. And in fact, here is a great big long running joint that goes almost all the way to the top. Um, it goes all the way to where these large stones are. And these large stones, I believe, were originally a kind of curbing on top of the bridge that would, basically allow the users of the bridge to have some kind of edge to guide them. Um, and so they were set lengthwise along the top. This one is actually has shifted outwards towards us a little bit, but it's still in a fairly safe place. And if you look up at the top, you can see another line of material here. It's not quite straight, and we'll get to that in a minute. But you can see this other line of material, and there's a little stanchion here and another one somewhere over here. I don't remember where. But these lines are actually the tops of concrete curbing that was probably poured around 1910 or thereabouts, somewhere in the window of, well, maybe 1890 through 1920, sometime there. And that concrete is important to us. We'll get to that in a minute. Here's looking at the same opening, the same vault from upstream. And here you can see again, the small voussoirs that I was mentioning, and the flattening. And here's a voussoir that, ideally these wedge shapes would be narrow end on the inside and larger end on the outside. Well, this one clearly isn't like that. Of course, we're only looking at the outside end, the ring, the arch ring, as it's called. We're not able to see, what shape is this inside. The only way to see that would be to dismantle it. Also here, you can see this little shiny area. And that shiny area is there because in the middle, there is a sag. So the vault actually sags even further in the middle than it does out here. And what you're seeing is the reflection of this reflected light here off the bottom stones, the ones that stick out the most. stick down the most. So this vault is, while it's still standing and is still reasonably stable, it's not in great shape. And that's one of the reasons why the bridge remains closed today, because we're not sure about how stable it really is. Here again, you can see some bigger stones on the top. Now, in 2021, some hikers noticed that there was a collapse or a partial collapse of one of the downstream spandrel walls, and um, we want to know why that happened, right? That's important. Why would that collapse occur? So if you look at this wall and pay some attention to the way it's built, you'll see there's running joints everywhere. I mentioned this one earlier, but there's running joints here, and there are lots of poorly chosen stones in here, stones that don't overlap very well. Here's another weak joint right here. The other thing about this wall is that it's only one stone thick, as we'll see shortly. So down here you can see some stones that are lighter in color, and that's because they were only recently exposed. They fell out from this area here. Let's look at that more closely. So here you can see this shadowy area here is where the wall has bulged out. And this bulge here, back in 2022, was probably about 3 feet beyond where the plane of the wall originally would have been. So this is a big bulge. And you can see here there's some soil. It's really more gravelly material, and we'll get to that again in a minute. Here's what happened 2 years later. So what began as a small bulge or noticeable amount of stone coming out turned into this almost total collapse of this section, this spandrel wall. And let's take another look here. So this area here remains more or less intact, and hasn't fallen at this point. We actually managed to prevent it from falling further. But if you notice, there's a whole series of stones here that are leaning against each other. This one leans on this one on this one, this one's pressing on that one, and this one in turn is supporting all of this stuff here. So all of these stones are basically dependent on these over here. So even though they've fallen out, they're still holding this up. And now let's look more closely at that bulged and the bit that remains. So there's that bit that we were just talking about that depends on all these stones below. And you'll notice this big hole here. And at the back of that hole, you can see bank run gravel. So that bank run gravel is all that is behind this one stone thick wall. And admittedly, this stone here is probably about 30 inches deep. This one's about 3 feet. There may be others that are about 4 feet long, but it's still only one stone thick. Now, anybody who's built anything out of, let's say you build a stack of firewood or a stack of books, if it's only one unit thick, it's not going to be stable when it's tall, especially if there's stuff pushing on it. And there's a lot of weight behind this wall. I mean, there's a whole roadway above it with vehicles that were going across it for decades. So why did this stuff not fall down right here when the rest of it went? Well, this stone at the top is one of those big long curb stones there. And this one here is this stone. So these are all pinned by this one here, which in turn is pinned by this one. And well, how does this one stay where it is? It's actually embedded in of one of those, the concrete of one of those curbing and pieces of curbing. So the concrete curbing that was installed at the top uh, is still in large chunks, and it's actually right here. You can see the concrete in there, that whitish stuff there. This part here, that's concrete with little stones embedded in it. And these two stones are actually uh, embedded in the concrete. There's more of that concrete right there. So the stuff fell out from behind, leaving this big gap. I could actually crawl into this space, and I did in order to fill it in later, um, later in the process. So there was a collapse in 1945 on the diagonally opposite wall. And here's what they did. So here you can see um, this is the area that uh, is under what was put in place after that collapse. This area here was where the collapse occurred. And here you can see it a little better. Obviously, all this vegetation makes it difficult, but there is um, a mixture of stone and uh, concrete curbing in this pile. So we know from that alone that what they did here was simply to pile material up against the face of the wall, and that provided enough support for the roadway above. So this area here is a little less tall than the bit that collapsed recently on the other side. It looks like there might have been a similar bit of um, reworking over here on the opposite side. So these are the two. This is the left bank and this is the right bank upstream of the bridge. Okay, so why did we decide not to build the spandrel wall, rebuild that spandrel wall that collapsed? And why didn't we just do what they did in 1945? Well, in order to rebuild the spandrel wall, number one, we would have had to remove a lot of material from above here. All of this would have had to be removed, and all the infill way all the way to the other side. And that would mean that this portion of the bridge would be destabilized because you'd have all this material here. So what would we do? Well, we have to take down this side as well. And in order to do that, in order to provide stability for the arch, the vault, we would want to put a formwork underneath it. And even then, given the condition of the vault, we don't know if that would have been enough to hold it in place. And it would have been very difficult to make that formwork. The estimated cost to do all of that is almost the same as building a new bridge. And we probably would have ended up building a new vault. And we're talking about hundreds of thousands of dollars, many hundreds, probably over $1 million altogether by the time all's said and done. So not really an option. Piling material here would not have been an option. It's originally what we intended to do was to make a revetment here, pile up rock and bring it up to the point where it would support everything. But in order to do that, we would have had to go into the stream, and that's not acceptable. We can't have a pile of stone in the stream here. So that left us with one option, and it's what we did. We built a wing wall. And a wing wall is basically a wall at a slight angle to the face of the bridge um, along the bank, and you will see that shortly. But here we are. So the but is we needed to get to the bank, right? To be able to reach this here, we actually built a platform for the machine, the excavator, to be able to reach this area here. The excavator had a reach of about 30 feet. We could have used a bigger one, but it would have been more awkward and much more expensive. So we ended up, in 3 days, we built this, and the machine was able to stand on top of it, as you will see. And then we started the process of rebuilding or building a wing wall. So here's another view of that platform. And there's that hole that we looked at earlier. And this stuff, this snake-like tube here, is actually it's called a wattle, and it's an erosion control measure, but it also serves to keep wannabe nesting turtles from crossing into the work area. So here's another view of that platform. You can see how the stones on the top of it are interlocked, and everything is very tightly built so that a 18-ton machine could stand on top of this with security. Here you can see those concrete curbs, and you can see how this one tilts here and then even more here. So there's a piece of it here, there's a piece of it here, and a piece of it here. And here's a stanchion sticking out. Here's another stanchion. What were these stanchions for? Well, they had pieces of timber, 6x6 timber, across the stanchions to serve as a railing. So that was their idea of curbing and railing in around 1900, I guess. Here's the machine in place, and we are setting, we have set here the first row of stones. So this is the bottom course of the wall, and beneath that is an area that was already there. You can see these stones were already here, and I filled in some of the spaces to make a bed for this first course of stone. So all of this is very tightly packed, and that's what we're doing here in this picture. Both of these pictures, we're taking smaller stones out of the bucket and putting them in and around and behind the bigger stones. So first we set the bigger ones, make sure they're well wedged in place, tight to each other as possible, and then we pack around them, trying not to leave any voids if we can avoid it. So here's halfway up the wall, roughly, maybe a little bit more, and this is how we got the big rocks in place. Our excavator was doing the job of the derrick in the 1800s, and how we strapped them. In those days, they might have strapped or chained or used tongs, and we chose to drill holes in the top of the stones. So one hole was drilled roughly in the centroid, or the center of gravity of the stone, and an anchor bolt installed right there, and a ring attached to that, and then a chain could be used to hang it from the bucket of the excavator. And then once the stone is roughly in place, I'm adjusting it here by hand, just making sure it's sitting in the right position. Then we would unhook the chain, excavator bucket swings out of the way, and we finish packing around the stone, and then remove the stub of the bolt that's sticking out of the top of the stone. So here's a view of that same area a little further up, when we've got a little further up. And you can see here, these stones reach in quite well, but this wall is much more than one stone thick. Look how deep we make it. It goes all the way back to basically the ground in here. It's all solid stone, and it's all fitted together more or less by hand. There's a few places where we might have trickled in some of this smaller stuff and then just packed it in, but most of it was set by hand. And here you can see uh, we're reaching the point of um, meeting the uh, overhanging stones in that little portion of remaining wall. So here's one level, and then this stone here is this one right here. So this is the next course, and you can see we've put a stone in there. Um, that's and this is where we're at now in this process. And here you can see I uh, built this out in order to be supportive of this one stone here. So this here is the remaining void, and we need a stone in here and then another one on top of it there. And there we go. So now this stone is actually supporting that one. And I just fit these stones very carefully. None of this moved, thankfully. It was all tight. And then I was able to begin the process of filling in this hole back here, initially with bigger pieces and um, later with some smaller stuff. So here we are that we're almost at the top now. And that's it pretty much topped out. Um, and we're going to start working on, you can see now how well, how solidly built this whole thing is. And here we're working on infilling behind the wall and ready to fill this hole, which we did like this. We put in 1.5 inch crushed stone that was well packed and shoveled right into the very back. That hole reached about 4 or 5 feet into the ground beneath these concrete curbing here. So this is the concrete curbing. And that dip there, um, that dip had developed over probably several decades. Um, we don't have photographic evidence of it, but it was definitely there for a long time because, and as you can see from the vegetation, that's above it. So the next step here is to provide a smooth surface on top of this. And that's what we did with this 3/4 inch crushed stone. And so now that's ready to have some soil spread over it. Before we spread the soil, in order to prevent the soil from being washed down this face here, this area, this slope, we actually put one of those wattles in this little channel here and then covered it with a piece of filter fabric and then set another wattle right behind it. And now this is hopefully going to retain all the soil that's going to come in above it. And there's the soil raked out. And on top of the soil now is broadcast some seed, grass seed, and then it's topped with a layer of uh, jute mat. It's basically a biodegradable mat, very loosely woven, but enough to hold the soil in place when it rains. So this entire area is now covered. The disturbed area is covered in soil, and here's the finished wall. We also added this little piece here because this was going to end up too steep. And we left this one in place, this wattle, to catch any soil that might make its way through here. This probably will end up covered with soil at some point, but DCR decided that they wanted to leave it as is, as being adequate. So here you see the finished wall, and it's pretty well integrated into the stonework of the bridge. You know, it butts up to it, and there's no space between the stones of the bridge and the stones of the wing wall. And with a bit of luck, this will do the job of providing the weight that this part of the bridge needs to be stable. So any arch um, like this, any arched bridge like this, has to have a load on it in order to be stable. And that load has to be evenly applied uh, on both sides of the arch. So you can't have less load over here than you have over here. Very important. Okay, well, that is the end of my presentation, and I'm ready to hear some questions if there are any.
So, if people want to put the questions in the chat, you should be able to do that. I'm just going to send a message to everybody. So the Friends of Quabbin actually funded this project, and there's some information here if you're interested in helping them um, pay the bill. So if you look in the chat, there's information about making a donation. Can you see oh, we got a Q&A here. Can you see the Q&A, or I can read the question to you?
Yeah, let's see, I'll go to the chat. Is that right? Is that what I'm looking at?
So Q&A is actually there's a if you go to the more so it should be a button on the bottom with the question mark says Q&A.
Um,
I can read it to you if you want.
where am I looking? I'm sorry.
Down
Uh,
on the bottom bar, next to
okay,
the
I've got it. Yep,
okay.
got it.
So Dorothy has a question.
Okay, so no, it is not granite. And so the question is all of the old and new stone granite? So there is some granite there. Most of it is actually a kind of gneiss, and that's Gneiss, gneiss. It's a German word, I think, and it's similar to granite, but it's not as easy to shape as granite is. So almost all of the stone that we used was local gneiss. There's a lot of it in the area. And in fact, the new stone all came, well, there's two different portions of new stone. So the new stone that was used to build the wing wall um, came from other sites inside the Quabbin Reservation. One site is maybe about a mile away, and the other one is maybe about 5 miles away. And I can't tell you the exact locations, but the stone is essentially the same, exactly the same stone as what was used to build the bridge originally. And then we also had that more angular stuff that was used to build um, the platform for the machine and also for the backfill. And that stuff is also a kind of nice, but it came from near Winchendon. Okay. Um, is Gate 30 now reopened for foot traffic?
No,
I
it,
don't think
it
so.
currently is not reopened for foot traffic. Not sure when that will happen, but it is something that DCR is, has a plan to reopen it at some point.
Yeah. So with that, having said that, though, I do know that the recommendation that I have given and which I believe will be followed is that the bridge itself should be closed to all kinds of traffic, including foot traffic, because it may not be safe. And there is a way that we could find out whether it's stable or not. It would involve a piece of machinery that costs about $100,000 altogether. So we'd have to have some, university or other lend theirs or something like that. And it's called a laser scanner. Basically, it takes many thousands of points on the inside surface of the vault and makes an image of that vault. And if you were to repeat that process, let's say every 3 months, you could see whether or not there was any movement happening. And so my recommendation is that kind of a study should be done. Um, and if there's no movement after a certain period, then it might be possible to reopen the bridge and say, well, we think it's safe. but we'll never know for sure, truthfully. Um, okay, so another question. Uh, Gina wants to know whether the holes that we drilled through the stones went all the way through. No, they did not. We only drilled them deep enough to uh, take the bolt, which is about 4 to 5 inch deep hole. Half-inch hole is all that's needed, uh, and the bolt goes into that. And the bolts are rated for about 3,000 pounds, and each of those stones probably weighs around 1,500 to 2,000 pounds. So they worked very well.
Um, Michael, let me just interrupt 1 second and go back to the gate 30 question. So I answered incorrectly. What I should have said is long term, I believe there's a plan to put a footbridge on that's upstream and next to the stone bridge, but I don't know when that would happen.
Right. Yeah, there's a number of possible ways to reopen the route that have been discussed, including maybe putting some kind of bridge over the very top of the existing one. But anyway, that's it's all speculation at this point. Okay, what has to happen with the curb and road surface over the span? Well, the curbing does not need to be um, dealt with in any particular way. My recommendation would be to uh, put some sort of railing system over it to keep people from getting too close to the edge. That's probably important. But you know, it's been the way it is for years, and nobody's ever fallen off the edge. So who knows? Um, and as for resurfacing or anything, I don't believe there's any plan to do that. Um, and is there any need for work on the upstream walls? Um, as far as I'm concerned, there is no need for any work on those walls because right now, although they're pretty rough, they're stable. So we would only do something if we were rehabilitating something that had problems. And as I mentioned, you know, rebuilding. Uh, if we wanted to rebuild the whole thing, we could do so, but it would probably be well over $1 million to do that. And it also wouldn't be the same bridge anymore. It wouldn't be the historic bridge that it is. Um, so there's an argument for leaving it alone.
And in terms of, vehicles going across it, there's no reason for any even work vehicles to go across it. There's gate 29 actually basically brings you to the same area, so it won't
Right.
have
And
access over it.
yeah, there's plenty of ways to get to that to the other side. Um, it's just a slightly more roundabout route. Yeah. And it would be nice to have that other bridge that you mentioned, Maria, the one upstream, because it would actually allow people to see the bridge from upstream. You can see it from downstream just by walking down the little slope to where the old abutments were, or are rather. Yeah. Any other questions? Okay, it looks like we don't have any others.
Yeah, doesn't look like there's any in the chat either. So again, oh wait, there is a new question in the Q&A. Here we go. Oh, just a thank you. You're welcome. Um,
Oh,
so
how long? Gina's asking, how long did it take? No, you mean the process of rebuilding, I'm guessing. So, um, or building the wing wall. That took about 4, 5 weeks. We started in October and finished in November. So yeah, around about 4 weeks of actual work. And that was with me as the dry stone waller, setting or guiding the stones into place, choosing them and guiding them into place, and one laborer and the operator of the excavator. And those guys did a sterling job. They were great. Mark Curtis and Trevor Chapman were my helpers there.
So yeah, Mark Curtis, it was his company, correct?
Right. So Mark Curtis was the excavating company that was in charge of uh, if you like, the overall project, and I worked alongside him, if you like. So we weren't subs to each other. Actually worked directly for the Friends of Quabbin, with whom we had our contract.
Which again, I'll just say it again, they are raising money to cover the costs. They were able to put the bill for part of it. They have the information on their website, or I did share their address in the chat. They currently only take checks, it seems. So, all
Yeah.
right. Um, if anyone has no other questions or comments, appreciate everyone taking their time to come. And thank you so much, Mr. Weitzner, for spending a little bit of time with us to go over this project and talk about how you were able to help shore up the cool Keystone Bridge out there.
Yeah, it's definitely a cool bridge. Let's hope it stands for a lot longer.
Yes, definitely.
All right. Well, you're all very welcome, and hope you have a good afternoon and a safe couple of days during this storm.
All right. Thank you so much. Bye,
Thank you.
everybody. Stay warm.
Thank you.